Hello and welcome. In this video we're going to be discussing lateral area of different shapes as well as the surface area of a sphere. So this is the formula sheet that you should have in front of you. Lateral area is talking about the area around an object or around a shape. And it's important that you do not include the top and the bottom or the surface areas of the sides, but not including the parallel sides. And we'll talk about that in 1 second. But these are the basic formulas that you have. Let's take a look at the first picture. Before we do that, let's just double check that we have the right lateral area. It should be 2 times L times H, not W. Thanks. This shape is obviously a rectangular prism, and if I was talking about the lateral area, I would definitely be talking about the front and the back, and I would also be talking about the right side and the left side, but I am not talking about the top and the bottom, so you want to be super careful here. But according to the formula that I gave you, lateral area equals 2 length height plus 2 height width. We're going to plug these numbers in. This is going to be my length, my width, and my height. So it's going to be 2 times 10 times 3 plus 2 times 3 times 2. And in this case, I wind up with 60 plus 12, or 72 centimeters squared. Try to remember that area is always squared in this case. Now be very careful. If I was to take this picture and actually rotate it on its side so that now it was standing up, you have to realize that technically we would have a different lateral area. And I wouldn't include the 2 and the 3. So worry less about the formula and more about the front and the back and the right and the left side of the shape, especially when it's a rectangular prism. Let's take a look at the next. So in this case, I have a cube, and the lateral area is going to be 4 times the side squared. So think about it for a second. There are definitely 6 sides in a cube, and typically if I did side squared, in this case I would get 25, and the surface area would be equal to 150 inches squared, but technically that's not what I want if I want lateral area. Lateral area is going to be the front, the back, the right, and the left, not including the top and the bottom. So instead of multiplying it by this 6, I only multiply it by 4. So in this case, lateral area is equal to 4 times 5 squared, or 100 inches squared. Okay, let's take a look at the next one, please. Now in this case, we're going to be dealing with the lateral area of a cylinder. And according to the formula that I gave you, LA equals 2 pi r h. So think about this for a second. If I told you that the radius of this can was 2 inches, then what you're going to do is lateral area equals 2 pi, and the radius would be 2. And the height, I have to give you the height as well. So maybe I said the height of the can was 4 inches. So you would put a 4 in here as well. Lateral area is equal to 16 pi inches squared. So whenever you hear lateral area of a cylinder, I want you to think of the label on a soup can. And if you think about the label on a soup can, it is actually going around the figure, in this case a cylinder, and that's how they determine how big the label should be. They find the lateral area. Try to realize that if we took a cylinder and we cut it open with a knife, we would have a big rectangle, and then we would have 2 circles that get attached to it. So this is basically the web diagram of a cylinder. This dimension is coming from your height in this case, and this dimension, which is along the bottom in this case, is the distance around the circle, otherwise known as the circumference, and that's where 2 pi r comes into play. So the lateral area is 2 pi r times h. Okay, let's take a look at the next. In this case, we're dealing with a cone, and a cone is a little tricky, especially when it's a cone that is upside down, or I give you what's called the slant height. So if I was to take this, I want you to realize that most cones are looking like this, so they're not technically a dunce cap, but more of a regular cone. Try to remember that if I was to give you the radius, let's say it was 7, and I gave you the slant height of 25, you would have to use your triplets or your Pythagorean theorem to realize that the actual height of the cone is 24. Remember, this is a 7, 24, 25 triplet. Now, in order to find the lateral area of the cone, it's going to be equal to pi RL, where L is the slant height. In this case, we're going to use pi 7, and the slant height is in fact 25. So technically we didn't need the regular height of 24, but in this case we're going to use the 25. The lateral area is equal to 175 pi, maybe it's meters squared. Now we would use this height of 24 for the volume. So remember, the volume of a cylinder is 1/3 pi r squared times height. This is a regular height and not the slant height. So the slant height is much different than the regular height. And in all cases, with right circular cones, we can make a right triangle out of the slant height, the regular height, and the radius. Okay, let's take a look at the last picture. So the last one is a sphere, and I think this is relatively straightforward, but if I tell you that the radius of a sphere is, let's say, 10 centimeters, and we're looking for the surface area, we're just going to simply use the formula that they gave us on the formula sheet. Surface area equals 4 pi r squared, so it's 4 pi 10 squared, and in this case it would be 400 pi centimeters squared. That's a nice, relatively straightforward, easy substitution, and we're just going into the radius. On this question, remember, if we gave you the diameter, you would definitely have to cut it in half to get the radius, or vice versa. So that would be a totally different question. In this case, the diameter would have been 20 centimeters. Okay, thanks, and I'll see you tomorrow.